Part C, x divided by x minus 1 is greater than 2. Solve the rational inequality. Okay, you don't have 0 on one side. You need to get 0 on one side, just like in that first example in part A. So what's the easiest way to get 0 on one side? So yeah, we're going to subtract 2. And then you can rewrite it as x divided by x minus 1 minus 2 is greater than 0. But there's an additional step. You want to get a single fraction on the left side. By the way, some people have a good idea that doesn't turn out to work out. Don't think you can clear out the denominator by multiplying through by the LCD. You can't do that with greater than or less than or any inequality because you don't know if x is positive or negative, and when you multiply through by a positive, negative rather, you flip the direction of the inequality. So you cannot clear the denominators here. Your only choice is to get them in terms of the common denominator and combine into a single fraction. So how do we turn x divided by x minus 1 minus 2 into a single fraction? What do we need to get? This is 2 over 1, minus 2 over 1. This is x over x minus 1. The operation is subtraction. We need a common denominator, don't we? So what can I multiply this minus 2 by? What is the LCD, in other words? So if I multiply that minus 2 by the x minus 1 over x minus 1, I can get a single fraction on the left side. Does everybody see what I'm doing? So I can write it down. We need, so in this step, what I'm doing is I'm getting a single fraction. Get a single fraction. And I can even say a little more. Combine terms to get a single fraction on one side, and then, of course, 0 on the other. That's the first step that you have to do. And then it'll look like the last problem after we do that. So, okay, think about it. I've got my common denominator. It's just x minus 1 here. So I'm going to combine these fractions right away. And then what do I have on top? X minus, I'll show this step, minus 2 times the quantity x minus 1. It's greater than 0. Now, I need to simplify, but does everybody understand to there? So do you see, are you starting to see how what you're doing now depends on what you learned before? Adding fractions is just a part, it's a small part of a bigger problem now, isn't it? So, Ryan, I think you were about to do this, right? What do you get when you distribute? Okay. And then we'll combine like terms. So what do we get when all is said and done here? So we'll get, x, a negative x plus 2, sure, over x minus 1, greater than 0. Okay? Now it looks a lot like the last problem. To get our critical values, it breaks down to setting the numerator and denominator equal to 0. So we're going to get, this is, I suppose it's step 1 of the method now. All this was preliminary. So step 1, critical values, CVs, we'll call them. It's supposed to be an S. CVs, critical values. So negative x plus 2 equals 0 will get us 1. That's the numerator set equal to 0. And x minus 1 is equal to 0. That's the denominator set equal to 0. That will get us the other. So I think we could solve those by inspection. What are the values? X equals 2. Also x equals 1. And then, go ahead.
How come you don't have to divide out a negative 1 on the x plus 2?
How come what?
You don't have to divide out a negative 1 to make the x positive?
Oh, right here?
Yeah.
Well, he did it by inspection. He just said, oh, what can I plug in here to make it 0? And it's 2 because you end up taking the opposite of it. Right? If you wanted to solve this more formally, you would subtract 2 from both sides and then multiply through by a negative. But then you'd have a negative 2 times a negative, you get positive 2. But no, he was, Another way to get the answer on an equation like that is just by inspection. Oh, if you plug in a 2 there, it's going to satisfy it, so I know 2 is the solution. Okay, and then the number line, right? We've got a 1 comes before 2 last I looked. So draw something like that. What number lies way out here to the left? Okay, it's not really a number, but...
0.
Well, 0's out here, yeah. That's going to be a test value, I think. How about negative infinity, yeah. And what concept? It's really not a number. What concept lies way out to the right? Infinity. Okay. So what do you suppose your 3 test values are going to be for step 3?
0.
Yeah, the left-hand interval from negative infinity to 1, pick 0. What about between 1 and 2? Yeah, you can't pick the endpoints, so you have to do a convenient decimal maybe. So 1.5 works. And then between 2 and infinity, 3, test value of 3. Okay, now it's really important you plug these test values into the right thing. You want to plug it into the one that is a single fraction on one side, 0 on the other. So you want to plug into this one. Okay, you could plug into the other one. It's just going to be easier to plug into the one that I indicated. Way easier. So what happens if you plug in, so let's do the test value of 0. What happens if you plug in 0 for x? So you're plugging in 0 right here, 0 right here. What happens if you plug in 0 for x? Just give me the sign on top and the sign on the bottom. Yeah, okay, on top you get 2, right? But what's the sign? Is it positive or negative? Positive. That's all I really care about. What's the sign on the bottom if you plug in 0? Negative. So it's a positive divided by a negative. And then you ask yourself the question, is that greater than 0? Is that a true statement? No, it's negative, right? So it's a big old no. Yeah.
Can you plug it into any equation?
Yeah, you could plug it into this one if you want. It's just easier to plug into this one. Yep. So you're not going to shade the interval from negative infinity to 1. And you might have the suspicion, oh, it alternates. The solution intervals alternate. So it's probably just going to be from 1 to 2. And then not from 2 to infinity. And in most cases, you're right, but there are certain situations where it doesn't alternate. And so you've got to go ahead and test all the intervals. In this case, it will alternate, but you don't always know that ahead of time. So if you plug in a test value of 1.5, I don't know why I said 4, because I had a 3 right there. This is all the same step. I did that without thinking. When I'm tired, I went to bed too late and got up too early. I woke up, I was already awake, but I opened my eyes and my son was staring over me. You know how kids do, they stare you awake? Well, he was trying to do that. But I had already been awake. I was just trying to get back to sleep. So anyway, when I'm tired, I say things backwards and I say dumb things. One time I was so tired in graduate school, I got a frying pan out to cook some eggs, and then I got cereal out and put cereal in the frying pan. They work you hard in graduate school. You don't get a lot of sleep. And not sleeping makes you dumb. I don't know if you've noticed that, but you guys really need to get your sleep, especially the night before a test. Don't stay up all night and study. You'll be worthless for the test. It's not a good idea. Okay, anyway, test value of 1.5, plug it in here. Okay, make sure you can see what's what here. That's a negative. I erased it, but that's a negative in front of the x, right? So if you plug in a 1.5 here, negative 1.5 plus 2, is that positive or negative? Still positive, right? Positive 0.5. And then if you plug in a 1.5 here and subtract 1, it's positive 0.5, isn't it? So is a positive divided by a positive, is that bigger than 0? Yep. So you're gonna shade. It's a big old yes here, and you're gonna shade between 1 and 2. What's going to be the symbolism in this case? Parentheses all the way because of the strict nature of the inequality, right? But just to be thorough, do the other test value. Plug in 3 for x here and here. And what do you get on top if you plug in 3? Negative or positive? Negative on the bottom. Definitely positive. So is this going to be a true statement? No. So don't shade here. So your solution just goes from 1 to 2. All x values between 1 and 2, not including the endpoints. Okay? Now, I didn't do example B, but I do want to mention it. It's a nice example. What do you have to be careful of when you find the critical values? It's a nice example in that it does something the other two didn't. It reminds you of something. To find the critical values, what do you have to do? Set the numerator. It's already got 0 on one side. It's already a single fraction. All that's done. So you have to set the numerator equal to 0 to get one critical value, right? You can see that's going to be 5, isn't it? Y equals 5. But you also have to set the denominator equal to 0. And that's the denominator is a quadratic, so you'll probably end up factoring it if it's a nice problem, right? But you'll get 2. You'll probably get 2 critical values, won't you, because it's quadratic. 2 more in addition to the one you got up top. So just be aware of that. So you're going to be using your skills that you've just learned to solve quadratic equations, although you learned it back in the factoring section, and most of those will factor. You won't have to use the quadratic formula on most of them. I just wanted to mention that. You could have, in this case, you'll have 3 critical values, which means 4 intervals to check, right? 3 critical values will create 4 intervals. There's always one more interval than the number of critical values. Okay, that's it for this section.